Hey everyone, welcome back to another video of LeetCode Daily Challenge Streak series, and in today's video we have a LeetCode medium question that says sum of subarray minimums. Now let's read the question. Given an array of integers ARR, find the sum of minimum of B where B ranges over every contiguous sub of R. Since the answer may be large, return the answer modulo 10 power 9 plus 7. Now let's understand this question with an example. So given an array and the elements, you are supposed to get the contiguous sub-arrays from this array, and for every contiguous sub-array, you have to find the minimum element out of all the sub-arrays, and then sum it up. And you have to sum it up and return the answer. Now, for this 3, 1, 2, 4, let's try finding out the contiguous sub-arrays. Now, it is 3, and then it's 3, 1, it's 3, 1, 2, 3, 1, 2, 4. Let's try to find out the minimum values in all of these. It is 3 here, it is 1 here, it is 1 again, and 1 again. Now it's 1 here, 1 here, 1 here. And it's 2 here, and again 2 here, and it's 4 again. Now, so what is it? 4 plus 2, 6, 6 plus 2, 8. 8 plus 1, 9, 9 plus 1, 10, 10 plus 1, 11, 12, 13, 14, 14 plus 3, 17. So the sum of all the minimum elements in the sub-arrays of the given array is 17. Now, how do we solve this problem? One way is to generate all the subarrays by generating all the subarrays, finding minimum for each of the subarray, and then returning the sum of it. But to generate subarrays for every given element, the time complexity would be O of n cube, which is very high. Now, what can we do to reduce the time complexity? How can we find out the minimum sum of all the subarrays within an optimized time complexity? Let's see how we can solve this. Now let's consider the same example 3, 1, 2 and 4. Now starting with 3, when we are here right now, what is the minimum element? It is 3 itself. Now we go to the second element. Now what is the minimum element until now? Till now it was 3. Now it became 1. Now let's move to the next element. Now what is the minimum element? It is still 1. Now let's move to the next element. What is the minimum element now? It is still 1. So if you can carefully observe here, if you have an element here, and if the right side of it, if to the right of this particular element, everything is greater than the existing element, then can you say that this element will be the minimum number of element in whatever subarrays these elements are present? Yes? Can you say that? In 1, this will be the minimum element. In 1 and 2 subarray, 1 will still be the minimum element. In 1, 2 and 4, this will still be the minimum element. So, if now here we apply the concept of monotonic stack. Now, what does this help us understand? If you see that the order is strictly increasing. Now, when it is strictly increasing, now the point you have started from is the minimum element, and no matter till where you go when it is increasing, the element you have started at will be the minimum, correct? And so with the number of elements that are to the right, when you try to generate subarrays in all those, so let's assume there are 3 subarrays. There are 3 subarrays with elements 1, 2 and 4. So with that, in all of those, if 1 is only the minimum element, so what can we add to the result? The question directly asks us to add the sum of the minimum elements. If in all the 3 cases, 1 is only the minimum, so can we directly add 3 into 1 to the result? Yes, because 1 is only the minimum element. Now, what if there's something like 3, 1, 2 and 0? Now you are at 1 and you go to 2, 1 is the minimum element. But then you encounter 0, 1 is no longer the minimum element. 0 becomes the minimum element. So everything to the right, if there were elements to the right, then you again start traversing, and and everything to the right will be compared and the minimum element will be checked. Now if you are at 1, for every element, you have to see what will be at which index you are encountering the next smaller element. Okay, from the current index you are always supposed to check where you are encountering the next smaller element or the same equal element. Okay, because as I'm telling you, the element should be in increasing order for the minimum element to keep repeating its minimum element. Now the question is very simple. Now if you look at the right, now till what subarrays again the 1 will be the minimum? Until there is another smaller element. Consider there is a 0 again here, there is 4. So within this range of 4, 3, 1 will be the smaller element. So for this 4, 3 and 1, if you find out the number of subarrays that can be formed within 4, 3 and 1 and multiply it by number of subarrays by 1 into the number of subarrays and add it to the result, you will still get this. Then you come to 0 and then you check for the minimum number of elements to the left and right. So it is very simple. So what we can do is we can maintain a stack with the index element and the value element, and for every element what we will do is that we will first start at 3. Okay, we will first start at 3 and we'll store the index and the value. Now we go to the next element. Whenever we find a number that is smaller to the number that is existing on the top of the stack, we remove the element from the stack. Why do we remove it? Because now the minimum is updated. Now it is changed to 1 and you want to see, because you are always trying to find the minimum number. So when you try to find the minimum number and after finding all the minimum numbers, you are trying to find the second part is to find the number of subarrays and calculating in how many subarrays it will be the minimum and adding it to the result. For now, we are just checking what is the next element and for how many subarrays this will continue. We came to 1. Since this was greater, we removed it. Now currently the index is 1 and the value is also 1. Now next we will move to 2. Since 2 is not greater than 1, we will append it to the stack. Now, so the index is 2 and the value is also 2. Next element is 4. So the element is 4 and the index is also 4. Now if you carefully observe, we have 1, 1, 2, 2 and 4, 4. Now this is monotonically increasing as in strictly increasing or increasing. Now at this one, if you carefully see, there are 2 elements to the right and 1 element to the left. So how many subarrays can this form? So if it's 3, 1, 2 and 4, if we are at 1, then we take the number of elements to the right, which is right, and number of elements to the left, okay, which is left, and multiply it by the element. Okay, so element into right into left will give us the sum of the minimum element in how many ever number of subarrays this element is in. If you carefully look at this 1, 1, 2, 2 and 4, 4, you can say that this 1, 1, anything below this element will be the minimum for all the repeating. If you take 2, 2 likewise, this 2, 2 element will be minimum for the elements that is below this thing. The same with 4, 4, it will be the minimum for itself. For example, let's take 3, 1, 2 and 4 and you are currently at 2. Now if you currently at 2, then the 2 is only minimum for the element next to it but not the left, to its left. So how many elements are in the right? 2. How many elements are in the left? 1. So 1 and it's 2. So 2 2s are 4. So now let's understand. So it's 2 here and 2 comma 4 here. So you have 1 element to your right and 2 elements to your left. So if you take the subarrays to your right, to which this is minimum, it's 2 and 2 and 4, in which 2 is minimum. So in all the subarrays that you consider, if you consider here, 2 is only minimum in 2 and 2 comma 4. So we've considered 2 and 2 comma 4. So this is the formula to see what is the sum that a particular element produces after being in a part of the subarrays in which it is minimum. So in whichever subarray 2 is minimum, what is the sum of all subarrays? For that only the formula is left into right into element. Now let's verify this. So it's 2 here, it's just math. It's 2 elements to the left, 1 element to the right, and you multiply it by 2. So 2 ones are 2, it's 4. Okay, it's 4. Now if you add minimum of this thing 2 plus minimum of this thing 2, 4. So 4 is equal to 4. Now you can see that. It is as simple as that. So for every element, okay, so for every given element, you just have to see in how many elements, okay, when you are at a particular number, you just have to see how many numbers are to the left and how many numbers are to the right, in which 2 will be the smallest, and thereby multiplying it with the element will give us the answer in the end. Okay, now let's quickly code this up. We have a function sum sub array mins given in which an ARR input is being given. Now, what I'm doing first, so before we write anything, since we are supposed to return the answer in modulo 10 power 9 plus 7, let's initialize a variable named mod, which has the value 10 power 9 plus 7. Now, when you write 2 asterisk, it means that it's an exponent. Now, let's initialize our result to 0 first, where we keep adding the minimum values. Now, let's also initialize a stack where we'll be storing our index values. Okay, let me just comment this out, where we'll be storing our index values and the actual number that we are iterating over. Now, what are we doing? For index and the number that we are iterating over in enumerate of ARR. Now, what does this enumerate function do? While you're iterating over, like I told you in the previous videos, this I value gets the index of the element currently we are at, and this n gives us the value. Okay, now if the array has something like 1, 2 and 3, this value, when we are at 1, this enumeration function will give us the index of this element as well as the value, which is 0 index and 1 element. Now, first what are we doing? We have to see if the element that we came across is less than the element that is on the top of the stack. The element that is on the top of the stack. For the top of the stack, which is the last element, it is -1 in Python. So since we are checking for the number, we are going for the first element. Okay, the first element of the stack. Now we are checking. Now there can be a while the number that we are iterating over is less than the stack, what we'll be doing? We will remove the element from the stack. Now there could be an out of boundary condition. If there is no element and the element is smaller, what can we do? We can't do anything. So we have to first check that the stack is not empty. Okay, we will pop the stack. Now next, what are we doing? We are taking the number of elements there are to the left and number of elements there are to the right. So left is equals to right is equals to. Okay, now let's take an example. 1, 2, 3, 4 and 1. Let's also note down the values of whatever we are popping. So j will be the index that we are popping out and m is the value that is in that index. So let's assume that our j pointer is at 2 and our I pointer is at 1. To get the number of elements between I and j, to the right of j, how many elements? It will directly be I minus j. It will directly be I minus j. Now the typical part is to find the number of elements to the left of j. So it is possible that when 2 is popped out, and when we came across 2, it is possible that the number that was before that is less than what was here. So to get that, what will we get? We will simply subtract from the top of the stack index. Okay, now this is only possible if there is something in the stack. We can only subtract and get the index value if there is something in the stack. So if stack. Now what is the else condition? If there is no one here and we are only starting from here, it means that there is no left. So we will simply add 1 to j. In the end, what are we doing? We are just applying the formula. So result plus whatever element that we popped, m into left into right. Now why are we adding result? Because previously there could have been a result. Previously there could have already been a computed sum for the minimum elements. Like if there is something like 1, 2, 3, 4 and 1 and we are currently at 2, there could be a previously computed sum for 1 that we have added into the result. So to add that and update the result value, we should add result. Okay, now this is it. In the end, what are we doing? we are just returning this result. Otherwise, if this element is not less than this thing, if this element is not less than this thing, what are we doing? We are directly appending the index and its value. Okay, I comma. Now, don't forget to put %mod here, because we're supposed to return the answer in modulo here. So we are going to do percentile modulo. Now let's get into the second part of the algorithm, where we'll talk about the elements, that talk about the indexes and its values that are present in the stack. So for I in range, len of stack. So the I here represents to the element in the stack. So for that, we have to take two other variables, say j and n, to get the values out of the stack, okay, where one will be the index and one will be the element. Now similarly, we have to compute left value and right value and its result again, correct? Now what is the left value? So for the left part here, it is similar to what we are doing. Since we need the left side of the elements, we will consider the elements that are before the stack of I, which is stack of I minus 1. And since we need the index, we will be taking the 0th index of this element. Now, since the out of bound case will be different here, because to check the out of bound case, we just have to check that the element, the stack element value will not go negative or 0 here. So the I value should be greater than 0. So if it's greater than 0, it is that, okay, else what we are doing, else it is j plus 1. Now what will be the right value? So for whatever is below, it is just nothing but length of the stack minus the current index will give you the number of elements to the right. In the end, what are we doing? We are updating the result. So result plus n into left into right, okay, result into left into right, again percentile mod, don't forget it, because we're supposed to return the answer in the modulo. Now let's quickly run the code. Submit it. This works. Thank you guys.